Let's go.
Are you ready? I think we're finally ready. Hello, everyone. Welcome back to Munro Live. I'm Kevin. I'm here with Armin. And behind us, we have a 2025 Polestar 3. So it's a pretty interesting vehicle. I guess that's one for the interesting thing count. But I think we're going to start real quick with the other side of the vehicle because we have a wheel cap pulled off. And we're going to talk about tires first, and then we'll get into the hoist for you portion of it. Mm-hmm. We did pull off easy aero shields because I know some people are wondering whether or not these vehicles are as exposed as they're shown on our hoist reviews. So aero shields that are easy to get off are taken off. And for those of you maybe that are joining us for the first time, you know, we do a lot of lean design for manufacturing, cost reduction, and things of that nature, right? For new product development, ongoing product development, things of that nature, and things like that. So
improve performance, reduce cost.
Yeah. Sometimes all three, which is always a good win for us. So we'll go around the other side here.
So
I'll get the parts for you, Armin.
Thank you, Kevin. So at Munro, we know a little bit something about wheels. And we'd like to point out that there is a lot of expense, no expense spared on really creating a very nice forged wheel. So it's forged, and then if you look at the surface finish of the silver portion here, it's actually done in a tumbling process. So these wheels are placed in a big drum with a stone media, it's tumbled. Then they put a clear coat over this, then they tape it off, paint black, pull off all the masking, and then finish it with additional layers of clear coat. And then even these covers that you usually see as just injection molded components from other companies are actually forged aluminum. So this is 6061, just like the wheel, and it pops in here. It looks like they had to do this to actually get that same special tumble finish on the lug covers as well. But this is just from a glance, might be up to $100 in just wheel finishing, right? So not even accounting for the wheel itself. It sort of seems that this is sort of the story all over the vehicle. They're really trying to build brand, kind of building on the quality and reputation of Volvo, from which Polestar sprung, right? Originally, it was the performance division of Volvo, and then as it was bought by Geely, they spun it off as their electric vehicle brand. So looking at the suspension on the inside here, the story continues with a lot of large castings and forgings. So the lower, it's a double wishbone suspension, the lower here is forged, the knuckle is forged, the fork is forged, the upper control arm is forged, essentially almost everything. The only thing that's not forged is the knuckle isn't forged, but on the bottom, if you look at how they attach the lower ball joint, in order to get that kinetic point as far outboard as possible, they went into add another forged bracket, which gives them a little bit more control over how everything moves dynamically. And so again, large Brembo brakes, very heavy duty. This is a relatively heavy vehicle. I think it's GVWR is around 6,000 pounds.
I believe so.
Something like that.
In general, he was here, but Carl was taking something apart, I think, for a seatbelt. But I kind of talked to him real quick just to give him an impression because he looked at the interior earlier. And, he felt it was clean, it was modern, and it was a good, enough content to justify the money that's being asked. And this is just over $90,000, I believe. I won't be buying one anytime soon, but you can see that just before we even talk about it, if you just glance underneath the vehicle, it is various states of aluminum, castings, forgings, extrusions, the entire way underneath the vehicle. So there's a lot of cost and just material costs and even processing costs with the vehicle.
So Kevin, before you talk about the crash structure, because this is a Volvo, and Polestar is continuing that safety first sort of brand identity. Extruded and welded subframe. Then you have your battery section, right? Pre-flat aerodynamic with friction stir welded extrusions for the bottom. We're not privy to see what it's inside, but They're likely relying on the extrusions for some of the anchoring, for the modules, etc. And then they have these two large die castings in the front and rear to really make use of all the real estate they have in between the axles, right? So there'd be modules in the front here with a casting and kind of bring it out as far as possible for module space, same in the rear. And then they do even have a penthouse for all the electronics that is kind of sitting underneath the second row. And so they're really trying to get as much modules in here. It's 111 kilowatt hours, which is pretty sizable for a vehicle of this size. That being said, it doesn't seem to be a very efficient vehicle. So if you look at 1100 or 111 kilowatt hours and 280 miles of range, if you do a quick comparison to a Tesla Model X, using that Tesla efficiency, they would get about 360 miles of range. So they're giving up 80 miles of range in summer, right? So it might be rolling resistance. These aren't aero covers, aerodynamics. So it's just something to be pointed out. In the rear, cast subframe and the suspension components are large but cast with a 5-link, or rather an integral link suspension setup, which gives you a great balance between performance and comfort. And then, Kevin, you want to talk about the crash structure? In the front?
Yeah, I guess we can go
it all
back
the
to
way
the front.
back.
Yeah, you took it all the way back right off the bat. That's okay. One of the things that kind of sets everything up, right? Like the whole vehicle is a system. It's using kind of a coaxial EDM, so everything is in line with itself with the rotor stator unit. So your shafts are kind of connected all concentrically, versus having like an offset gearbox with a lay shaft driving power, which is sometimes more packaging efficient. So you can kind of see just the overall width. The Lightning had a similar execution as well as far as its drive modules. So the drive module is driving like an overall packaging consideration here. Then we have some extruded aluminum front cradle. Most of it's extruded aluminum. I'd be curious to see in the future if they start integrating this with the Rivians early on. Very similar execution, a little bit more complex. And then eventually they started to throw in castings as well. But this pushes out your overall width for this vehicle. And if you were to kind of take a look up here, Eric, so you see these large extrusion here, and then there is a winglet off to the side here. Now, in a lot of other vehicles, that would be like essentially like a dedicated SORB strategy or small overlap rigid barrier. But you can kind of see, if you can bring in the camera and look forward in vehicle. So we have the extrusion, the isolator, for this, and then the stanchion here for the motor bay rail. So on a lot of other vehicles, you'll have tusks and other dedicated structure that push past the threshold of the motor bay rail to engage the barrier. And it might be difficult to see if I can ask you to look back down here and then straight up and rearward in vehicle. So again, the overall width is pretty wide here, but you can see that the motor bay rail is even wider and it's splayed. So from the dash panel moving forward in vehicle, it's splayed. This allows you to kind of keep your dedicated like offensive or front of axle SORB structure to a minimum. The one thing I kind of like about executions like this, much like when we reference Kias, and this is definitely not a Kia, this structure here is being used every pothole you hit, everything you do as far as driving this vehicle, the material that was bought and paid for to help with SORB is being used by you as a customer all the time. It's not just out here hanging out parasitically. It's there and it's part of essentially every crash script that you would have. Full frontal, moderate, and small overlap itself. But that's one thing that's kind of interesting. So they do have a very large splayed rail, a layered kind of stanchion coming down to this outrigger itself. And then you may be able to see on top of this, so it's got this large rectangular extruded section. If you look through the front, but on top of this running completely across car is a steel tube with some stamp brackets that kind of interface with the outriggers that we just spoke to. And then straight up is another extruded section, and there's a series of like diagonal pencil braces that are running up and grabbing like the upper, so you'd have essentially the motor bay rail, the cradles down here, and then upper load beam structure, sometimes called shotgun structure, all being tied together. And this is like an actual threshold. So you do have, your AGS, subfascia AGS, fascia, there is an impact beam, and then it's cooling components for the cooling module. And then this is a literal plane that goes straight to the vehicle. There's nothing else hard or protruding, no compressors, no anything else. It's a literal threshold here, which is oftentimes very typical for free crush space. So you have the initial, energy absorption structure. It'll start to give way during the impact. A lot of this is, timing derived and trying to mitigate pulses. But there's literally and this vehicle is actually pretty easy to see, a literal threshold of where hard components or, very rigid components are allowed to start again with the vehicle. Mm-hmm. So kind of in summary, due to the EDM style, it pushes everything out and it allows a lot of that structure to be complementary for most of your crash scripts. So we'll see whether or not they start ditching extrusions and try to do a little bit more integration, but it does give them, a lot of ability to, let's see, does this kind of nests over, but slip a little bit cross car and adjust as they need to through manufacturing process. Mm-hmm. But even around this drive module itself, you can kind of see a little bit that, there's a pump here, there's a small casting, on the pump itself. There's a lot of actually use of smaller castings in and around the front drive module. The mounts themselves are integrated. So you can see here, it's going forward and piggybacking somewhere off this threshold that we kind of spoke to before, where that steel cross member is, where the Lightning that had separate mounts, but that seemed to be like we'll see how many platforms are built off this, right? But the forward drive modules for both front and rear look very much set up to be put in essentially any vehicle they decide to, right? And you have vehicle-specific mounts reaching from vehicle to EDM. This seems to be, a little bit more set up to be in passenger vehicles itself. Did you want to add something?
I'm wondering, I don't actually know this, but the Polestar 2 was built drivetrain agnostic. So I don't even know if they have an ICE version on that chassis. With this, I'm not too sure. Just looking at it, do you think there is room for an internal combustion engine here, the way it's laid out?
So from like a transverse powertrain, yeah, you probably could. The issue here, right, is with an ICE engine.
I'm asking because they have a tiny frunk.
Yeah,
if you look at the front of this, there's, it's like a couple liters, right? You can put your charger in there, that's about it. Sure. And trunk space on something that's just a BEV is,
like a premium.
You're probably leading the class from the bottom.
I don't know. It's hard to see. I didn't see anything, from the upside or trunk or frunk pulled out or anything like that. But we did see. So the top, structure here is what appears to be the reservoir for the air suspension, and then in the past, if you were to look at any of Volvo's like upper body structure, which they do have essentially cast aluminum shock towers, they've always had a lot of mass there, and that's helped them essentially hit a barrier specifically for small overlap and skip off, right? Volvos, or I guess Polestars now, that'd be one of the few vehicles I might volunteer to do like a small overlap collision and might.
For the right number.
Yeah, because they typically will hit the barrier, they skip off, and they keep going. With not a lot of like cross vehicle or wide like yawing off the barrier. Some will hit, they're very defensive and they rotate off the barrier itself and kind of move away. Some are very rigid and then shoot off the barrier and kind of put you at risk at a secondary impact. The Volvos holistically will hit the barrier and they kind of keep moving. All that mass is just going forward through the crash event.
If you guys want to see Kevin personally sorb test this vehicle, drop it in the comments.
Yeah. My wife won't approve. But to your inquiry about ICE, right? So when you look at this cradle, so we have these rear crosscar extrusions, and then this looks to be about the threshold for the dash panel. So you can see the steering rack here if you want to take a look. So it's very hard to see. Everything is very, very tightly packaged, but there's the steering rack here. There's another casting that's sitting on top of it. And then this is all potentially encapsulating the sway bar itself in between the cradle and maybe even the body. It's very, very difficult to see. But one thing that is kind of unique, you can see all the high voltage connectors here. And as Armin was kind of alluding to, there's this very large casting in front. I think the last vehicle I took a look at here was the BYD Shark. That had just oodles of room between all your major monuments. I mean, literally you have essentially a 10 to 15 millimeter gap between your cradle which in many ways I'd consider like the bare minimum for like dynamic
Yeah.
clearance, right? You know, not that these are moving too much separately of each other, but there is some. And then this casting starts. But I'm trying to think of some of the past vehicles where there was either shielding added to this or
The Lucid kind of
other,
had a similar
or
setup.
other features to try and keep you from hitting like road debris up and hitting here. The entire leading edge of this is closed out and protects all your high voltage connections in the front very, very well. So, and you know, with these features kind of brought in, the aero shields kind of close out just this limited portion, and then the battery is doing the rest.
Should we take a look at the rear here?
Yeah, just one small point. So the front is doing like an injection molded or thermoformed wheel liner. In the rear, they're doing like a PET or a soft one, which is, especially from like the lot, much better for MVH perspective. This will be a little bit tingier, but we've been seeing a lot of people trend back to these. There's some data, you know, like longer in life, these tend not to be as good for certain aspects of NVH besides like stone impingement, you know, like constant pecking. Yep. Yes. Yep. So, but they do PET in the rear, which is kind of interesting. Yep. So, and then what you can kind of see here, aside from all the body decking points, looks like airlines, battery coolant, and there's a lot of rubber and a lot of connections on this. It's real difficult to show you guys, but it's from a cooling and cooling line perspective, it's similar to the early iterations of the Mach-E as far as connections and use of EPDM lines, but also brake lines. So, and this is mirrored on both sides. So it looks like whatever fluids or systems are being run, you know, front to rear, are running down each side respectively of the sills. So both coolant, brake, and air run down on the sills.
And then while we're speaking about the sills here, from the press release we saw, there's actually extrusions that we can kind of make out that are protecting the pack, that are welded to the underbody extrusions. So you kind of see that here. But then there's also more impact extrusions in the side sill of the body structure, right? And so we can't really see that right now, but kind of goes in line with what Kevin was talking about in the front. There's a lot of material to protect the car and the occupants as well as the battery pack from intrusion in a side pole or a T-bone accident. Coming to the back here, one thing that we saw, we don't exactly know why that is, but we see two pumps that are attached to the rear EDU. This vehicle does disconnect the rear under light load driving, so it becomes a front wheel drive vehicle, and there might be a hydraulic disconnect in the EDU here to reduce some of that rolling resistance. Again, the question is, why do you have two pumps? Quite notable, can't make it out without taking this car further apart, but definitely curious. Looking at our air suspension in the rear here, it is quite notable that this is not even a conventional air suspension with a single chamber where you compress a gas to give you a spring force instead of a coil spring, but here you have a dual chamber setup which lets you essentially change your spring rate. So with air suspension like this, you don't only get different spring rates, but also different ride heights. So we have an accumulator, air reservoir that can rapidly refill the air volume in the suspension, thereby raising the vehicle, and then a valve will let it off. This comes, with a lot of benefits. You can, on the highway, you can drop the vehicle, reduce the CD, get more range out of it, or if you're off-roading, the vehicle can raise it a little bit for a little bit more clearance. Additionally, you get a lot of cool little aspects. For example, this vehicle, when you want to load something in the back, it'll drop for you a couple inches, right? So it's a little bit easier if you have something heavy to get it in there, and then it'll just raise back up as soon as you close the rear hatch. And so while it's very expensive, it comes with a lot of performance benefits and functionality. However, and you can talk to that, Kevin, a little bit, they're not the most durable systems, right? So traditionally, you probably have seen it before when you see a vehicle like an expensive Mercedes kind of squat down like a dog. That's somebody that can't afford to fix their air suspension, right? So
yeah, I mean, and they've gotten much, much better. I had a good friend of mine that was on the air ride team for the Ram. he used to kind of joke that everyone that works on Air Ride, none of them drive vehicles with Air Ride, or at least buy them. But there's a lot of different ways to do like active suspension, right? But one thing I would say, when you get into using air as the medium to give dynamic performance, in some ways it's a little bit more straightforward as far as like the pressure and how fast you can move air throughout the system itself, in contrast to some other hydraulic setups or or Magna Ride or things of that nature. So I think when it comes to there is a lot of cost here. Not only do you have the bags, you have the lines, you have the pump, the compressor. So it's a pneumatic system. It's a electro-pneumatic system with all that stuff. And every joint is a failure point as well. But there's, from a cost perspective, and this is some things that we often get into, right? It's a little bit easier sometimes, I think, to define the cost of these systems and maybe defend the cost of these systems in contrast to other technologies, for instance, like Magna Ride, right? Where there's some proprietary aspects to it. It's difficult to fully understand whether or not, you as the OEM, when you get a line item cost for this, and you're like, does this really cost this? It seems like it's a shock with some fluid and sprinkles in it, right? And just a sensor. And they're like, yeah, but it's proprietary. So, if you were to do like a should cost on a system like that versus a system like this, you'd look and see that, an OEM can like maybe justify this cost a little bit better because they can define it versus some of the other active suspensions that are out there.
And then maybe one thing we should mention is this is not a damper, right? So this is the spring right here of the vehicle. Any suspension system in automotive will have a damper and a spring. It's two components. The spring actually carries the mass of the vehicle and gives you your spring constant. So it does the springing, and then the damper controls that motion, right? So it bleeds off some of the energy that's in the spring as it moves. And so oftentimes people look at this, it kind of looks like a damper, but bigger. It is not the damper. The damper will be this component here. And so you can have, when people talk about active suspension, both of these aspects, the damper and the spring, can be active. Large casting in the rear for the, or sand casting for the EDU cradle. Pretty common, right? So different execution from the front, slightly different strategy. Maybe this is shared with other vehicles, and you have volumes that justify the tooling and development costs associated with this type of deal compared to extrusions. Usually when you have vehicles with lower volumes, maybe less of a budget, it is much more efficient, not only on the engineering side, but how much you pay for tooling, doing something that's extruded and then welded together, sort of a space frame type of.
Yeah, you end up with lots of assembly stations, lots of weld stations, lots of quality checks. With that, a casting like this, I'm not even sure if they do like an FDI or just like an X-ray check. But sometimes, like a low pressure or sand casting, tooling is also pretty low. It's when you get into high pressure die castings and things of that nature where a lot of the burden with all those work cells starts to work their way up. And maybe also why we don't see any extrusions running cross-car. A lot of times people will flex using extrusions
Looking
running
at this
cross-car.
giant lower casting, and this would be a die casting for the lower arm of the IntegraLink. I think, is it a hollow? Also, it's also a sand casting. It's not a die casting. So this is actually, a giant section. This is actually hollow casted. I think that they could get away with designing this less voluminous from a structural perspective and performance perspective, but I almost would guess that they like to blow this up a little bit for aerodynamic purposes. So oftentimes you see plastic spats and aero covers that you attach to suspension to clean up the airstream. This is ultimately important on electric vehicles. And you do even have on the toe link in the front a little bit of an air cover underneath. Notable, I think that's the only steel in the suspension at all, is the toe link in the rear.
No, I think you're correct. Not only that, they might like that as it comes down, and then just looking, you can see where all these material drop points are. I also wonder, right? Sometimes if you were to run the analysis on this, maybe we can get away with a smaller part. Are we adding material just for material flow? And also what, Armin is saying, right? Like, is there a system aspect where we can cheat down on some separate parts or improved aero? It's always fun from that perspective of trying to balance all requirements and what you need for.
And that's kind of what we do for our clients as well, right? Looking at things, big picture, system integration, trying to weigh and optimize all those different aspects, right? Whether we're looking at whether you should do, what type of manufacturing method, at what volume is the right choice for your vehicle. These are our core competencies, and we like to bring vehicles in like this to keep a pulse on the industry and to see what everybody is up to. Here in the rear, this looks like it's the charger module. We're charging from the back on this vehicle. Interesting that they have a little reinforcement here. I don't know if that's a bit of an afterthought, but.
Yeah, I mean, maybe, right? It's not like overly material efficient. They took as much as they can out. So, I mean, this is a stamping that's, or even, it may not be stamped. It looks like it is just with these recesses, but, a lot of steel was bought to make that part, but who knows? Maybe it's only for a particular variant. When you look through the casting here, there's nodes for, each side of the inverter here. This looks like the pedestrian speaker, which I kind of dig this. Like, I don't know what is retaining it, but it's, yeah. And so I like that they have this, but you can see that everything is kind of reaching out from a systems perspective and talking to each other. I don't know if there's like a pin or something that keeps it from, rotating back out, or another feature on the top side of this, but we advocate a lot for, features like this if you can. You can also see a relatively large, mass dampener on the top here. But it's, more likely due to the weight. We have the cradle, the casting here. This is touching off and it knows the inverter. And then it's also supporting another bracket. So another function with the pedestrian speakers. So at least this component, while separate, it's doing a lot of work. Also has some locating features, probably for when this assembly is being brought to the rear cradle itself, depending on how it's built online, whether this all comes together or the cradle goes in, this comes in later. It depends. But
we should mention the fastening strategy on your
fork.
Oh
yeah, right? We kind of shot past it. One thing that is, let's see, just to make sure you can see here as well. So, nothing too crazy here, right? Bolt through for the toe link. It's got a nut. But on here, they're adding material, and there's, no captive fastener on the other side. And they're doing the same thing on the front as well.
Yeah, so they're just threading the casting here, eliminating the nut, which gives them, you might not be able to assemble things, right? You don't have the packaging space here to put a nut on there. But if you're working on this car and you mess up these threads, you have a real problem, right? It's not a straightforward fix. They use the same on the front, even though here you clearly do have the space for a nut. No big deal, but again, the fork here is threaded, and that's how this bolt is fastened for the suspension.
Is there a quality check, Armin, on the front bolt?
There's a quality check, one I see here for the knuckle, but that's the only one I see.
So there's one on the rear that I kind of just spoke to for the complementing strategy there, but there's not many. So a lot of time early vehicles, you'll see just every fastener point. I think we saw this with the Rivians early on. 1, 2, sometimes 3 checks. There's not a lot here. There's not one here. There's a dot here on this point. There's one here, one in the rear. So that is one thing that's also kind of worth noting is whether from its welds or like actual fastened joints, not a ton. And frankly, when you look at it, it's all on key like safety structure, right? We have brake sensors here, a key joint here, and that's kind of, it seems like all that is needed.
That being said, Polestar is not a Rivian, right? So they sprung out from Volvo. They've been around, they've been manufacturing vehicles for decades, and Geely, same thing. Been making millions of vehicles over the past years. So it kind of feels like a startup. Right? And they are definitely trying to build brand with all their design and expense they put in the vehicle here, trying to position themselves as European or American luxury competitor, but it's a startup, but not. Right? So I think the vehicle makes a very good impression. Right? You get something for your money.
You do for sure. You know, it'd be, I don't know if we ever have planned to tear one down. It would be interesting to see. We saw some of the castings, right? You know, they're coming out of China, which is quite common, especially for unique or low volume stuff, you know, to source it there and bring it over. But there's a lot of cost in the underbody. It's not akin to some of the other vehicles we see where there's a lot of profit and markup. I do think you generally get something for the money that's being spent here.
Yeah.
Is there anything else you wanted to add?
Anything else? I think that's about it.
Yeah. So overall, it's pretty interesting. I actually would love to take it apart. It'd be kind of maybe a shame, but we'll see. Maybe in the future we'll get a chance to. So thanks for tuning in. We appreciate it, and we'll see you next time.
Okay. Thank you very much. Bye-bye.